Supposedly, as a physical science student, we were given this question: 30 gram of hydrogen is mixed with 35 gram of nitrogen, and then the question says determine the limiting reagent. Now, what is the limiting reagent? And brief explanation. Suppose you are having 18 slices and 4 cheeses. Obviously, you're gonna get 4 sandwiches, right? So to determine the limiting reagent, we'll determine it by what's the word of English? By the quantity. The smallest product will be our limiting reagent, and the largest product will be our access reagent. So you know that you're given an examination guideline that will help you to define the limiting reagent. If not, you can go to your science prep to get the definition. Then we need to make sure that our equation is balanced. As you can see, we have 6 hydrogens and 6 hydrogens, 2 nitrogens, and 2 nitrogens. Okay, the reason why our hydrogens, they have a suffix of 2, the hydrogen and the nitrogen, is because of these two are diatomic molecules. Okay, let's identify the limiting reagent. We're going to take the 30, going to calculate the number of moles of hydrogen by mass over the molar mass. The mass of hydrogen is 30, that is divided by the 2 molecules of hydrogen, which is 15, which is 15 mole. Sorry about that. And then I'm gonna calculate again the number of moles of nitrogen, which are, we're given 35 grams of nitrogen. Number of moles over the mass for molar mass, which is 35 gram all over 2 into 14 equals sign, and then this will give us 1,25 mole of nitrogen. Then we're gonna compare the ratios. You need to compare the ratios. And how do we compare the ratios? We are applying stoichiometric calculations. Let's take the hydrogen and then we compare it to the nitrogen. We know that the number of moles of the mole ratio for hydrogen, it's 3, and then for nitrogen it's 1. Then we have 15 mole, and we're looking for the excess nitrogen. If we multiply the 2, we're gonna have 3x, that is equals to 15. Then by dividing both sides by 3, we will have 5 mole of N2. Then we're going to do the same thing this side. HN3:5. This time we're going to look for the excess hydrogen, and then we received 1,25, which is the mole ratio, it's 1. So it's 1, and then this is, it's 1,25. We're gonna have x, that is equals to 3,75 mole of hydrogen. From there we're gonna look for the excess. These are the required. We're gonna look for the excess moles, The excess mole for hydrogen will be the highest mole of 15, will be the highest mole of 15 minus the smallest mole of 3,75. This will be 11, 11 something, I don't know, 11 what. And then we'll have N2, which is the highest. It's 5 minus 1,25. It's gonna be 3,75 mole. This is 11,56 or something like that, in this range. Then you're gonna compare. Okay, the hydrogen, it is in excess with 11,56. The nitrogen, it is in excess with 3,75. The smallest number is this one. That means N2 is the limiting reagent. Even if you check the moles, we have 1,25, we have 15. Yes, this is how you determine the limiting reagent.